Yeah, thank you for the invitation. And today I want to present our development called Cardiff, which is a research data infrastructure for material science. I hope you can see the slides completely because sometimes there are some black borders on it. Cardiff format is supposed to support a close collaboration between experimentalist theorists and simulators, especially in the material science. But the material science discipline is highly heterogeneous, so a lot of different disciplines are involved: chemistry, physics, and so on. So our goal is not to focus on one specific discipline, but to help to let these people collaborate and have joint projects with each other. Therefore, we have a lot of ongoing projects which are involved. A lot of them are part of battery research, but we have also a joint project with partners at KIT developing ChemMotion, and we are also involved in the NFDI initiative, NFDI for Engineering Science. More information about Cardiff can be found at this URL. And here's a conceptual overview of Cardiff. So we have a working area which we call electronic lab notebook, or nowadays more virtual research environment. And this is the part where you can work with your research elements, so with your devices, and keep record of your research. And therefore, we provide access to a huge range of data handling tools, which should hide you the complexity of the technical infrastructure, which consists of computing facilities, devices in your laboratory, as well as different storage places in your laboratory, in your desktop, in different computing facilities, and also the backup mechanisms which are necessary to ensure your data accessibility. Therefore, we split it, Cardiff, in four subtopics. One is Cardiff Web. One is which is the accessibility through a web browser. We have Cardiff Studio for your working environment. We have Cardiff FS, Cardiff file system, so you can access all the technical infrastructure, especially the storage space. And we have Cardiff ML. This is an example of Cardiff Web. Here on the left-hand side, you see an overview of a record with the descriptions with relations on the bottom. So you can link your different results and descriptions with each other. And on the right-hand side, you see, for example, a preview of your stored data inside of Cardiff format. This is a plug-in interface, so it can be extended for different needs and purposes, and also for different file formats. This is an example of Cardiff Studio. So to enable and describe your workflow for your research, we have built a workflow editor with a graphical interface, what you can see on the left-hand side, where you can specify your input parameters. You can describe in the green box your environment, for example, on a remote computer or a HPC facility or a laboratory equipment. In the blue box, you see a task which should be executed, and the gray boxes are the input parameters which might be fixed or can be changed during the execution of your workflow. On the right-hand side, you see an example of the user interface, what you see if you execute a specific kind of workflow. Here you see, for example, selection mechanisms for chemical elements. And this is a good example in the extension to the previous talk. Here we want to connect to materials project, and that might be enhanced by using Optimate. Yeah, so here you have the possibility to interact with the workflow, but also automatically track your input parameters, so you don't need to record them in a separate electronic lab notebook. With CardFS, with the file system, so you have access to the records. So we have already seen the web interface, but we have also a Python implementation, which can be used as a Python library, as well as a command line tool. And we have especially a special feature where we can mount records into the file system. So we can read and write in a record of Cardiff format directly as it would be a folder in your file system, and therefore you can use any kind of proprietary software, which does not need to be aware of Cardi. You can just read in the data sets directly and write it back to your records and have stored it in Cardi, and they are available there, even if the software has no features to do so. This is just a generic example of the machine learning part. Here, what we want to build up by tracking all that information and data that we have a database, what you see on the left-hand side. Then you can train your models, can predict adaptive designs, select promising candidates, and do further simulations and experiments to validate that, which can be put back in your database again. And therefore, we also develop a framework which is called HITS tool, and this smoothly connects to Cardiff. And here is a real-world example. So on the right-hand side, you see in the center all that knots. Each of that knots represents a record. The colors represents different kind of records. So on the right-hand side, on the top, you see a record which has all micro-CT images stored there, which are extracted by that red dot, which represents a tool which can reconstruct that 2D slides to a 3D image. And from that 3D image, we capture a lot of statistical informations. And then we have a second red dot, which represents a tool which can generate artificial structures. These artificial structures are stored in a separate record. And then we have that blue KIDS record, which represents the training mechanisms on all of that records, and they are stored as a trained network. And this trained network at the end can be used for predicting of new structures and structure behavior. Therefore, by using Cardiff format, you can build up your own ontology bottom up. You just use it and then enhance it and extend it by storing new records. You can track your research work by connecting all the records, share your results with your colleagues, so you can grant access to all of the knots individually. You can reuse your information like device descriptions, workflows, description of methodology, and metadata templates, so that you can reuse a lot of your previous work and enhance it over the time. Cardiff format is not meant as a standalone tool. So therefore, we aim to connect to a lot of different available systems like repositories, Zenodo, Radar for Kit, or Chemotion. We have a lot of tools which are already adapted to be smoothly working together with Cardi, like Octave ImageJ. You can generate PDFs by using LaTeX. You have a lot of visualization tools available. We have also enhanced ELAB FTV, for example, to more smoothly work together with Cardiff, and so on. Yeah, and this is our team actually working on Cardiff format, and thank you for your attention.